The next part of our work will involve linear inequalities. Okay, linear inequalities with the name, we see that in this case it's just like linear equations. Well, we said initially that inequalities exist with this different sign, the greater sign, the less than sign, greater than or equals to, and less than or equals to. So the linear inequalities are going to be linear functions which are equated or inequated with a certain number because we are in inequalities. Now, let's take an example. If we have a linear inequality as such, 1 less than 3x plus 1 divided by 4 less than or equals to 2. Now, this is an inequality. If we are asked to find for the range of value where x is for us to have this inequality. If you are asked to find the range of values where x exists for us to have this inequality, we say that this inequality have a certain function y equals to 3x plus 1 all over 4. And we say that 1 must be less than y, which must be less than or equals to 2. Now, if we plot this graph, we realize that the graph will be something as such. Now, they are asking us that now in this graph, the line y equals to 1, line y equals to 1 is shown on the value 1 as a horizontal line as such. And the line y equals to 2 is shown on this graph as a horizontal line on 2. Let's put 2 for as such. Now, this inequality states that we are going to take value between this point where it touches the cube, between this point of the y equals to 1 and this point where the graph touches the line y equals to 2. So we are going to have this range of values where x will exist for us to have this function. Now, you have to put in mind that here it's excluding 1. So the value of x that you're going to put is excluding this value 1 and including this value 2. So on a graph, this is how it is represented. You are drawing this linear graph and you plot the different y lines. You have a y1 and you have a y2. The interval of x that exists in between the two regions of y are what you are asked to calculate, y excluding the x which is excluding y equals 1 because they just say less than, and including the x which produces a y equals to 2. So let's proceed in the calculation. Now, you see that 1 is less than 3x plus 1 all over 4 less than or equals to 2. This is the initial equation that is given to you. Now, using the rule of that we have seen already in inequalities, we will see on rule 3. Rule 3 says that I can multiply with the positive side without affecting my inequation. So if I multiply here by 4, I'll multiply here by 4, so I have 3x plus 1, and then I multiply here by 4 plus an 8 here. So I've represented my table of inequalities. Now, I can continue by saying this. Either I work with this side and this side, but this one will be longer. I can either work like this and say 4 is less than 3x plus 1 on one side and work with 3x plus 1 less than or equals to 8 on the other side and find the values on each side. Then I compare and put them together. But that one is longer. So I'll take a simpler method by saying 3x plus 1 is less than or equals to 8. I bring it on the other side, then I bring it on the other side because I'm working with two equations at the same instance. So if I subtract here by 1, I will subtract here by 1 and I will subtract here by 1. So it's the second law of the rule of inequality. So this gives me 3 is less than 3x. Here is 0 less than, this one is 7. And now I'm capable of dividing all the sides by 3, which is the fourth law of inequalities. And I multiply, I cancel all around, so I have 1 less than x less than or equals to 7 over 3. So we see that x is going to exist at this region. The value of x is going to exist at this region. Why excluding 1? So if I substitute 1 in this equation, I'm going to have 1 on this side. So I'm going to exclude 1 here and include 7 all over 3 as x. So this is the final answer. The range of value where x is if you have the equation 1 less than 3x plus 1 all over 4 less than or equals to 2. So these are linear inequations. The next one to move with will be a quadratic inequation. Now, the second one, point number 2, will be quadratic inequations. Okay. Quadratic inequations are just involving quadratic functions which are inequated. That's just a simple definition. Quadratic functions which are inequated are equal to quadratic inequations. Now, let's take a simple example. Example here is 2x squared plus 3x plus 3 is less than 3. If you ask 3x plus 6 instead is less than 3. If I'm asked in this case to find the range of values of x for which this function exists, we already know how it's going to say. Now, the first thing to put in our mind is to plot. If you want to find where this function exists, the first thing that I put to my mind is how is it possible? This function here can be drawn as such. We see that the a here is greater than 0, so it has minimum turning point as we have seen in quadratic equations. So we can guess that our graph is as such. Now this line, this is y less than 3. We can say that this function is y, so x squared plus 3x plus 6. Now the line y equals to 3 is y. What's the line y equals to 3? We have y1 here, y2 here, and y3 here. So the line y equals to 3 is a horizontal line as such. Now, everything that will be underneath, because it's less than 3, everything that will be underneath the line y equals to 3 will respect this inequation. So from this point here to this point here, on their graph and having this range of value of x, we are going to be in this inequation. So let's try to find the inequation, the range of value of x which will respect the inequation above. Now we know that 2x squared plus 3x plus 6 is less than 3. Anytime we want to proceed with this inequation, the first step I have to do is to reduce the other side of the inequation to 0. The step 1 that I have to do is to reduce the other side of the inequation to 0. So it's 2x squared plus 3x plus 6. I bring on the other side 3 less than 0, so I've reduced it to 0. So now I have 2x squared plus 3x plus 6 minus 3 gives 3 less than 0. Now I can try to either proceed by factorizing method or completing the square method. The completing the square method is not going to work quite alright, but so the first thing I'm trying to go with is by factorizing method. Factorizing method is going to give you an answer. Or the second thing I like going with, if the factors are not coming out, the second thing I can do is to find for the quadratic, which use the quadratic formula. So in this case, I can use x is equals to negative b plus or minus the square root of b squared minus 4ac all over 2a. And then I can have each value of x. X1 will be negative b plus the square root of b squared minus 4ac all over 2a. And x2 will be equals to negative b minus the square root of b squared minus 4ac all over 2a. Now, when I'm going to find the two values of x, x1 and x2, I'm capable of saying that if I equate, I know that x1 will be equals to this. So x1, I bring on the other side, minus into negative b plus or minus plus the square root of b squared minus 4ac all over 2a. It will be equals to 0. And x2 is equals to, no, minus into negative b. Now, in this case, will be minus because I use plus here. The square root of b squared minus 4ac all over 2a will be here, and all that will be equals to 0. I know that if I multiply this here I found with this here I found, in 0 is equals to 0 in this case. So I'll end up by having a factorization which involve the two different quadratic formulas, either with a positive and a negative. So that's how I do it. I perform it when I have a function which is not capable of being factorized. For me to factorize, I will use the quadratic formula to find each of the values of x, and then I put it on other side and have x1 minus this, or instead x. This is still x. x1 and x2 are both x. So x and x minus the different values of the x are found with the quadratic formula are going to be equal to 0. So if I multiply them, I'm going to have a form of factorization. So I'm going to calculate the inequality. Now, so let's come back to this question. This question, we have 2x squared plus 3x plus 3 less than 0. Now, for us to proceed in this question, 2x squared plus 3x plus 3 less than 0. For us to proceed here, we need to find for the critical values. The critical values are the values which make up the bound of the inequation we have to form. Now, let's come back to our graph that we have here. The graph we have here shows us that there are certain bounds which are the limit of the range of values that we have to find. Now, the critical values are going to make up the bounds of the inequality you have to find. So, for us to have those bounds, we are going to say step 1 to equate this to 0. We take the function 2x squared plus 3x plus 3x plus 3 less than equals to 0 in this case. Now, let's see, is this capable of being factorized? If I do 2 times 3, we know that in factorization, the first thing to do is to multiply the a times 3, a times the c, we have 6. Then I guess two numbers which can add up to give 3 and multiply again to give 6. I see that it's highly difficult to have it. So I'll proceed by the second. I say that it cannot be factorized. Cannot be factorized. Now, so I'll proceed by the second method I've initially told you by way of quadratic formula. So what I do here, let's say we had something that could be factorized, and let me show you how you have to do. If in this case we had inside the equation 2x squared plus 5x plus 3 equals to 0, we're going to have 2x squared. We could factorize by multiplying this and having 6. We can have 2 and 3. So we have 2x squared, 2x plus 3x plus 3 equals to 0. So we factorize it as such. And now you're going to have the bounds of this function as such. You take x plus 1 equals to 0 and 2x plus 3 equals to 0. Now 2x plus 3 in this case is not plus 3x plus 3 equals to 0. And your value here at the bounds are going to be negative 1, x equals to negative 1, and 2x is equals to negative 3. Divide here and find x equals to negative 1 all over negative 3 all over 2. So that gives negative 1.5. So you're going to have x equals to negative 3 over 2 at one bound, and at the other bound you're going to have this. Why? In this case, it's less than, so you're going to exclude them. So these are how you're going to have your bound if it could be factorized. Now let's use by the second method initially to you by quadratic formula, because this equation that we initially had it was not capable of being factorized. So how will I proceed? I will try finding for x while using quadratic formula. X in this case will be equal to negative b. B here is 3. Negative 3 plus or minus the square root of b squared. B in this case is 9. And b squared gives 9 minus 4 into a. A is 2 into 3 all over 2 into 2. Now, I see that 9 minus all this value is not capable of being formed. So I'm going to have an x which is an imaginary line. So this equation I've initially had was false because it is imaginary. The value of x here is imaginary. But let's guess that in this case, we instead had another value of b which should be 7. So in this case, the inequation won't exist in the real value of x element of r. So let's get now that b was instead 7 in this case. So 7, we're going instead to have x equals to negative 7 plus or minus the square root of b is 7. 7 squared is 49 minus 4 into 2 into 3 all over 2 into 2. So we have 4 that way. So we are going to have your two values to factorize it as such and say that you can place it on the other side and have this other side as 0. So x minus into negative 7 plus or minus the square root of 49 minus 4 into 2 into 3 all over 4 times 2 times 3. 4 times 2 gives 8 times 3 gives 24. So all over 4 will be equals to 0. So I can have a factorizing method in this case that is as such: x minus into negative 7 plus the square root of 49 minus 24. 49 minus 24 gives me 25. So in this case, I have 25 here divided by 4 all times x minus into negative 7 minus the square root of 25 all over 4. All that will be equals to 0. So I have factorized this inequation that was not capable of being factorized by using the quadratic formula. So when factorizing it, I can find the bounds as such. Now, those cases were slightly complex, so we're going to take a simpler one. The simpler case will be this case, less than 0. In this case, I can easily factorize by multiplying here by 2. 2 times 3, I have 6. I find for two numbers that will add up to give, so it's 2 and 3. So this gives me 2x plus 2x plus 3x plus 3 is less than 0. And then I factorize it as such: 2 into x plus 1 plus 3 into x plus 1 is less than 0. So 2x plus 3 all into x plus 1 is less than 0. Now, for me to proceed with this inequation, I'm going to find for the critical values. The critical values is when I do the quadratic equation above, and I equate the quadratic formula above, and I equate it to 0 to find the bounds. Because we initially agreed that in this initial graph, you are going to have a bound where the line you are asked to find for y less than the line y equals to 3. So it will exist between this point and this point. Those bounds, we know that in the quadratic equations, in this case, either 2x plus 3 will be equal to 0 or x plus 1 is equal to 0. Now we're going to have 2x is equal to negative 3 divided by 2 divided by 2. So x in this case, first case will be equal to negative 3 over 2. Or x will be equal to negative 1. Now, negative 1, negative 1.5, and negative 1, which one is less than negative 1.5? So, on your bound, you're going to have negative 1.5, which makes the lower bound, or negative 3 over 2, is the lower bound. And negative 1 will be the upper bound of our range. Now, we see here that in this case, it is less than and not less than or equal to. So it implies that the value of negative 3 over 2 and negative 1 are excluded in our range because it's not less than or equal to. In this case, we see that on the line y is equal to 0, let's say that this function is 8. On the line y equals to 0, it's going to be between this one and this one. So the range of x will exist here. Now, the thing that we have to have in mind is that when we say y is less than 0, it will not include the point, this point, and this point. And this point and this point are the lower and the upper limits as such here. So it will include only the points which are down on the curve, which are inside here. So here we are going to exclude the value. We are going to exclude first this value by putting an open circle and excluding this value by still putting an open circle. Now let's test the different zones in which we are found. For us to have this inequality for the range of value in this inequality form, we know that to test, this is negative 3 all over 2. Negative 3 over 2 is same as negative 1.5. A value which is less than negative 3 over 2 is negative 3 or negative 2. Let's take negative 2. In order for us to work, we are going to take this negative 2 and come back to this inequation here. You see, negative 2, we place it to this function. 2 into negative 2 plus 3 all times negative 2 plus 1. The value, is it positive or negative? That's what we're trying to find. So 2 times negative 2 is negative 4. Negative 4 times 3 is going to give a positive or negative value is going to give a negative 1, which is negative value. I just maintain negative because I want to find the sign. Negative, and I say negative 2 and positive 1 here gives a negative still. So negative times negative is going to give me positive. So at this side, I'm going to have a positive. So let's take the second zone. At the second zone, here is between negative 1.5 and negative 1, you have negative 1.2. So I can place it here and test. 2 into negative 1.2 plus 3 all times 2 into negative 1.2 plus 1. So let me test. 2 times negative 1.2. 2 times negative 1.2 plus 3, we see that this times this will always be less than, the magnitude of this will always be less than this one. So I have a negative value which is less than this, so all this will be positive. 2 times negative 1.5 plus this. The value of this will be greater than the value of this. So I will maintain the sign, it's negative. Positive times negative give negative on this side. And lastly, I come here above this one. Above negative 1, we have 0 on the normal line. So I can place 0 here. You know that 2 times 0 gives 0. 3, we have a positive 3, so outside you're going to have a positive. And 0 times 1, we have 0 plus 1, it gives a positive 1. So we have a positive also. Positive times positive give me positive. So now this is how our number line will exist. Now, the thing we need to ask ourselves now is, how are we to find this inequation from the number line we've just found? Now, anywhere you see that the inequation above is written as 2x squared plus 5x plus 3 less than 0. So the thing that you have to put in mind is the inequation, the quadratic function must always be less than 0. So anywhere we see that positive, yeah, is it greater than a positive value? Is it greater than 0 or less than 0? So you see that positive value is always greater than 0. So we are going to exclude this. This other positive value, a positive value, is it greater than 0 or less than 0? So a positive value is always greater than 0. So we exclude this other side. So the sign which is going to be included will be found between this and this. So the range of values that you're going to have is x negative 3 all over 2 is less than x is less than negative 1. So this marks the end of the quadratic equation. Thanks for your kind attention.